Okay, ladies and gentlemen, let us continue with our discussion of the atom. We have already talked about the basics of the atom, and now I'd like us to talk a little bit about something called nuclear chemistry. So, to begin that, let us consider this. We have a reaction between CO. What is CO? Carbon monoxide, and O2, oxygen, in which electrons are shared to form CO2. CO2 is carbon dioxide. Now the question is this: is this a chemical or is this a nuclear reaction? Okay, I think we need some notes on this. So let us begin here and let's talk about reactions a little bit. And in chemistry, there are really two types of reactions that we discuss. The first are chemical reactions. And we'll spend a bunch of time talking about chemical reactions later. And there are nuclear reactions, and we're going to spend the rest of this chapter talking about them, the rest of this unit. Now, what's the difference? In a chemical reaction, we have something happening with the electrons. That's right. What happens here is electrons are shared or transferred. That is what happened. Transfer? No, how about transferred? There we go. Are transferred. Electrons are shared or transferred. And where does this happen? This happens in the electron cloud. Now, what's the electron cloud? Well, the electron cloud is somewhere outside of the nucleus, and that's really the most important thing for us to understand, is that chemical reactions are occurring outside of the nucleus. And so it occurs in the electron cloud usually, and the electron cloud is outside of the nucleus, and it's hard to say exactly where this occurs because, as you'll learn later, it's hard for us to know. In fact, it's impossible for us to know exactly where an electron is. And so we call the most likely place of an electron an orbital, and the collection of these orbitals is an electron cloud. So let's just say for the time being that in a chemical reaction, electrons are shared or transferred outside of the nucleus. Good. And what about a nuclear reaction? This is a reaction which takes place in the nucleus. And usually in this case, this is a case where in the nuclear reaction, somehow the nucleus changes, in which nucleus changes. Sometimes it is transformed completely, and other times it just loses some energy. Good. So do we have enough to answer this question here, this consider? We have a reaction between CO and O2, and what do we notice? Electrons are shared. Aha, electrons are being shared. That means this is a chemical reaction. Good. So that's how we can tell the difference between a chemical reaction and a nuclear reaction, right? We have electrons reacting, transferring, being shared versus a nucleus being transformed or losing energy. Next question. Consider bismuth 209. Is this a radioisotope? Yay, yay, yay. Radioisotope. What is that? Sounds like a band out of the 80s, doesn't it? No, it is actually a term we use in nuclear chemistry. And it looks like we're going to have to learn some more about nuclear chemistry here. So let us come back here. Let's clean up my chemical side and give us some more space. And let's work from my nuclear side. So we have nuclear reactions, and we want to talk a little bit about some, let's call it nomenclature, meaning let's learn some words, some vocabulary related to nuclear reactions and nuclear chemistry. And the first, I guess, we should learn is radioisotope. Good. So what is a radioisotope? A radioisotope is, really simply stated, an atom, an element, an atom with an unstable nucleus. That is a radioisotope, an atom or an isotope with an unstable nucleus. Good. So let's add something else. This is radioisotope. So what do we know so far? Hey, if it's radioisotope, that the question then we're asking is, does bismuth 209 have an unstable nucleus? That's the question. Can we answer that yet? Not yet. We have to learn more. Good. So now let's move on from radioisotope and let's learn a word that you've probably all heard before, you have all heard before, and that is radioactivity. Good, radioactivity. Now, what is radioactivity? Radioactivity is, and I like this definition, the spontaneous disin, disintegration, spontaneous disintegration of an unstable nucleus, spontaneous disintegration of an unstable nucleus accompanied by emission. That means spitting out, right? Emission or throwing out, emission of particles and or energy. Good. Spontaneous disintegration of an unstable nucleus accompanied by emission of particles and or energy. Now here's the cool thing about this. What is this really? This is a process, right? And there's a process to do what? It's a process by which a nucleus, and what kind of nucleus? A radioisotope, we could say, right? By which an unstable nucleus gains what? Well, it's unstable, right? So it goes through a process, and what do we expect to happen after it goes through it? Well, if it's unstable after the process, we feel that it should gain what? Gain stability. Now, it doesn't mean it gains complete stability. An atom, a radioisotope might go through the situation, the process of radioactivity, and gain some stability, and then later go through more radioactivity, express more radioactivity, and gain additional stability. So radioisotope, that is the thing, right? It is an isotope with an unstable nucleus. Radioactivity is what an unstable nucleus goes through, right? It's the process of disintegration. It means the nucleus starts to break apart in some way. And when it breaks apart, what does it do? It emits, it shoots out particles or energy. Good. And associated with this is another term that sounds very similar, and we have to be very careful here, and it is radiation. And what do you think radiation is? Well, radiation is that energy and or particles emitted by an unstable nucleus. Hey, I see the picture now. We've got a radioisotope, right? A radioisotope here, right? It's unstable, so it is radioactive. And its nucleus does what? Spontaneously disintegrates. And when it spontaneously disintegrates, what does it do? It emits radiation. There we go. And so now we have a whole picture of this idea of a radioisotope, radioactivity, and radiation. Now, can we answer our question? Bismuth 209, is this a radioisotope? Bismuth 209. Well, how am I to know if it's radioactive? Right? That's the question we're asking here. Does this have an unstable nucleus? How can I tell? Well, we need to come back and talk a little bit more. Let's go through this side here. Let's come up here and let's come down, and we're going to have to extend the page, aren't we? We need much more space. And let's come down here and talk about the causes of radioactivity, right? What causes an unstable nucleus? And I like to break this down, and there are two general causes, I guess, an external cause and an internal cause. or really there are a couple internal causes. And what's an external cause? What could cause a stable nucleus to become not stable? Well, if it is bombarded by other particles, or if it captures energy in other particles, this could lead to a stable nucleus becoming unstable. On the internal side, that means what I'm talking about here is just from nature when it was formed, is there a problem with the way it was formed which would lead it to be unstable? And there are two reasons why. There are two that I want to talk about why a nucleus can be unstable. One is a high proton to neutron ratio. That means there's too many protons in the nucleus for it to be stable. That in a stable nucleus, we have so many protons and so many neutrons, and they're in a certain ratio. If I have too many protons, then that nucleus will be unstable. Or the flip side, a high neutron to proton ratio. Good. Now, how can you give me a rule of thumb about when I can expect something? What is a high proton to neutron ratio or a high neutron proton ratio? Well, that's really tough to say. Here's what I can tell you. Roughly, if you have a proton to neutron ratio or a neutron proton ratio, which is equal to or approaching 1, that is usually stable. So if I have a new proton to neutron ratio, which is about the same as the neutron proton ratio, and it's about 1, then that's stable. If it is greater than 1, then we start having some instability. And it's like I say, it's really tough to give you a specific answer. But here's what I can tell you. Any element above bismuth. Now, what I mean by that, bismuth above, what do I mean? More protons. And how many protons does bismuth have? 83. Any element with more protons than 83 is radioactive, meaning it has an unstable nucleus. So that's kind of the rule of thumb. Anything greater than 83 on the periodic table is radioactive. Now I think we can answer. Bismuth, hey, there's our buddy bismuth. How many protons does bismuth have? It has 83. Good. Right away, we're going to guess what? Hey, if it's bismuth or greater, is it a radioisotope? Yes. Now, just for the heck of it, let us look at this proton, let's look at the neutron to proton ratio. I have 83 protons. This is my mass number, right, folks? Mass number. So what does that mean? It means I have 126 neutrons. Would you agree with me on that? Yes. So that means I have 126 divided by 83. And so what is 126 divided by 83? 126 divided by 83. And it looks like it's 1.52. So when we think of something as a high proton to neutron ratio, something in the range of 1.5 is certainly a high neutron to proton ratio. Got it? Good. Next, here we go. Consider carbon-12, uranium-238, and polonium-212, which are likely to be radioisotopes. Okay, I'll give you a few minutes or a few seconds to figure this one out. Okay, carbon-12. Hey, let us come back to carbon-12. Let's do the easy ones first. Uranium-238 and polonium-212. Uranium, how many protons does it have? Uranium has 92 protons. Is that greater than bismuth? Is that greater than 83 protons? Yes. So what are we going to say about uranium? It is radioactive. Polonium-212. Polonium has 84 protons. Is that more protons than 83? What's my guess then on polonium? I would say yes, it is radioactive. Now, just for the heck of it, let's look at the ratios. So it looks to me like I have 146 neutrons. Is that right? Yes, it is. Divided by 92 protons. What's my ratio there? 146 divided by 92, and I get up something like 1.59. Oh yeah, that's a high neutron to proton ratio. And what about for my polonium-212? How about what do you think? 8, and that makes that 9, 128. You buy that? 128 neutrons to 84 protons. 128 divided by 84, and I think I get 1.52. Hey, I'm starting to see a pattern that if I'm in the 1.5 range, it looks like I probably have a radioactive isotope. Now, carbon-12. When I look at the periodic table, I see carbon has 6 protons. Okay, so right away I'm thinking, okay, carbon-12 probably is not radioactive, but I still need to check this out. It has a mass number of 12, so that means it has what? 6 neutrons. When I look at the proton to neutron ratio, it's 6 over 6, and that is a ratio of 1. And so if it has a ratio of 1, I'm going to assume that it is stable. Cool, ladies and gentlemen. Well, that's about as far as I want to go right now. Give you the intro into nuclear chemistry. Next time, we're going to talk about nuclear reactions and really get into the idea of radiation. And that's pretty cool stuff. So until then, bye-bye.